Good morning. How is everyone? Going to be working on a short stream today, getting some 3D text rendering in Godot. Hey, Jemmett, how's it going? Came across one of your comments and I think it was a bug report in Godot the other day. But I tried using the 2D and 3D scene as an example, and the font rendering just didn't come out to the quality I wanted it to. So I think that we're going to do some mesh building for glyphs and layout in Rust. Get some font rendering in 3D. Morning, Mr. Ed Makes. You know what? I forgot to turn back on my scene switcher. Let me do that. There we go. Well, let's see. Is this in a state that I can actually run it? It might be. And hopefully we can see what it looks like right now without too much trouble. You know what? Let me make sure that OBS is picking that up. Okay, it's not. Tell it where that is. Godot. And if you ever see like a black screen like that, let me know. All right. So here's our little scene. Double check in OBS. Great. I'm gonna give this a run. Now, what I do have in this scene is actually 3D text, or 2D text in a 3D space. But I might have broken it already. Let's double check. Screen. Yeah, I think I deleted a bunch of stuff already. So I was using this label with some text so we can see multiple lines here. And it's supposed to be wired up to this mesh here. So we're basically using a viewport in order to render one camera's view into another. However, when I did this, no matter what settings I used, the text always came out looking awful. Anti-aliasing around the edge just wasn't up to par. It looked really out of place in the rest of the scene. Say, yeah, it's not. I don't want to spend too much time getting that working again. Just so I can show you the kind of bad state. We're going to go ahead and work towards getting the good state because I don't have a lot of time this morning. So, back to term 2. Now, what is this going to look like? Okay. And what are the steps to get this working? Where's my A sprite? Ah, here we go. Zoom in here. Now, we've got a 3D space at one end of it. Right? So over here, we've got some beautiful world with 3D text. And we're going to represent the 3D text with this little squiggle. That's beautiful, gorgeous text because we have 3D models, like an A, like a 3D mesh. Okay. Now, somewhere in the middle, we need a mesh. I'm going to draw character A. And this is our representation. Oh, this is gorgeous. Of the character that is starting out in some sort of font. Okay. We're going to have some sort of font, either, let's say TTF, we'll just say true type font for simplicity, some sort of font asset. So we're going to have something like this, and it's going to need to become some sort of 3D mesh. That's an H. So we have the TTF, and then we have some big question mark here. Now, that big question mark is going to be a whole bunch of Rust code, and there's going to be a little bit more Rust code over here as well. So Rust to Rust. Now there's a couple of solutions. There's, oh, I did take a peek at the, good morning, gentlemen. at the plugin that does it pretty well. I want to do it in Rust though. Not toString. Yes. Morning, Commander Thrashton. Yeah, I needed a string, so this is one way of doing it. So we're going to take a TTF bit asset, embed it into the game, and then at runtime we will generate our font. You stay for the artwork? This is high quality stuff. I mean, the amount of effort that went into this, it's unreal. The amount of training. Yeah, because quote quote in Rust is going to be a borrowed static lifetime stir. And my type needs it to be an owned string. So we're going to be filling in this gap here today and a little bit more of this gap over here. Now we have a little bit of experience with the gap on the right. With this one on the right over here in the red, we've done stuff like this before where we've taken and tessellated a mesh or tessellated some data and tossed it into Godot. We've done that before. And so we're going to be using Lyon, L-Y-O-N, L-Y-O-N, and line geometry for the tessellation bits. And then to get the tessellation bits, we need to use some other sort of font parser, which I have decided to use. Morning, Xenocron. Let's look in here. Okay, so we have a TTF parser, which is a wrapper around, so owned TTF parser is a wrapper around TTF parser that uses owned data. It'll make some things a little bit easier for us. We're going to be using that in this place over here. This is owned TTF parser plus Lyon equals these big, gorgeous meshes that we then toss into 3D space. And then, of course, we'll have to build out some sort of layout engine, which isn't all that difficult because TTF parser will be able to provide us all of the glyph info. And I'm hoping to use a monospace font anyways for the game. Ooh, a joke. Why are skeletons so calm? Because nothing gets under their skin. That's good. So we're going to start with Roboto, Mono. It's regular font. We are embedding that into the game, const function, to slice view8s. So this, I was surprised. It's not very big. It's incredibly small. Hey, Xenocron. Well, thank you for the resub. Or a 7-month streak, yeah, continuing that. So if we look here in assets, let's see. Rust assets. I only have Roboto. And it's only 125k, which is surprising to me. I thought it would have more, but it doesn't. I wonder how they can get away with that. Does it not have all the glyphs? I mean, it must have quite a few glyphs. Anyhow, trying to get back to Cargo Watch. There we go. So we've embedded that. It's not going to bloat the app too much, which is nice. And then we're going to have our struct, our type that we're going to be using inside of Godot. Okay, here's a German joke. Hopefully you can translate it. What's 3 times 3? No. Oh. Oh, that's great. Yep. Ah. Okay. A little bit. It's funnier than I thought it was going to be. That's a good one. I'm going to torture the children with that. So the first thing that we're going to do is load up our font into this owned face. And so we convert the font to a vector, say, hey, we want face 1, and we enforce that, hey, this must be parsable, and we have this owned face. Great. So we're going to save that here. I don't know if this is the best place to store this. It'll be a place. That might change. Then when we go to render, we will iterate over the string that this text element has, and we will pull up and generate a new glyph for each one of these. Now, one of the reasons I'm unsure of where these things are going to live is because it's very possible that we want to have multiple of these control elements. Think of it as a label in Godot, but a 3D label. What comes between sex and fear? 5. All right, then we have bounding box. So what we're going to do, we're going to have this hash map of characters, and this thing here, the self.characters, come back after this, it's a hash map of our chars, or car, to a glyph. And glyph is my type. We're going to store a bunch of stuff in a glyph. So we have the string, got the hash map of those elements, and then we've got a font face here. Arguably, this hash map should live outside of this, and we'll probably move that in the future. And the reason for that is because of how we're going to be doing the mesh. We're going to be using multi-mesh so that we can have a lot of characters without... what's the right way to say that? Multi-mesh allows us to have many of the same mesh on screen at the same time without a performance hit. Now, I don't plan on having that many meshes on screen to begin with, so it's overkill, but I think it's going to be a learning exercise. Now, going back to where we were, we'll insert something into the hash map. Well, we check to see if it's in the hash map, or we insert it with this awesome function, which is in progress. So we have this font face. Overkill is your middle name. Yeah. Using Rust when JavaScript will do. It's over. So I like Rust for other reasons. I'm going to try to make the argument today at work for using some more TypeScript. Actually, TypeScript at all in our code base. I think it would help us avoid some bugs and be able to operate on the code faster. Our code is vanilla.js, and it's good code, but it's growing and could be easier to manage. Painting overkill rules. Yeah. See, that's one of my concerns. You've seen it firsthand. As any type. I used TypeScript from version 0.81, 0.8.1, or 0.8.3. It was 3 maybe. and watched it grow up, using it for many years. And each upgrade, it would actually find bugs in our code, which was just incredible to see. Hey, your code doesn't compile anymore. What? Why not? Like, oh, it's it's wrong. The code's wrong. Yeah. All right. Oh, yeah. So that's going to be my chore today. I've got to come up with a very short presentation on the merits of TypeScript and types to a bunch of people that know Ruby and JavaScript. Coming back here, we will get the glyph ID from the font face. Okay, so we pass it the car. I always say char. I hear people saying it different ways. I like to pronounce it phonetically for some reason. Instead of character, I say char. Like that. Anyhow, glyph ID. Then we build up one of these gorgeous things, this glyph mesh builder. And that thing's going to be used to get the drawing information out of the font face. So the TTF parser is going to give us this information via this builder. It actually gives us two pieces of information, the bounding box for the font and the glyph drawing instructions. So if we look at the glyph builder here, it's going to be collecting stuff into what I'm calling a mesh. Arguably, we could say it's a set of instructions, but inside of here, we're going to use Leon to collect these into a set of drawing instructions. So we're going to wire that up today. That's enough of the backstory. We're going to start wiring it up now. I think I still need to get Leon in here. Yeah. See what features it has. Experimental is interesting. I looked at that yesterday or the day before or last week, whenever it was. And it uses some non-mint types. It just uses plain types, like F32s, etc. It looks like we can just toss that on there. What else does it have? And this is the same tesslator, I think, that Servo uses or Firefox uses. Or it's somehow related. It has no binaries. Oh, I'm not in a place where I can do that. Oh, I did that wrong. Cargo add. There we go. So now we have Leon. I'm going to use that in here. But we need our sort of mesh. We're going to look at the documentation on Leon. We're going to want to build a path out of this. You can see they have begin, line 2, quadratic, cubic Bezier 2, and end, which which is basically what we're going to be doing. And then they have a fill tessellator and build that out. Get the tessellation, unwrap it, etc. Yeah. All right. Let's pull up the docs on this. While the example is nice, I'm going to pull up the docs. Path builder. No. Is it just called path? All right, and where does that come from? It's one of these sub-projects. That's right. Leon is a collection of projects. Collection of crates. So, Leon path. Now, I thought this was re-exported. Yeah, this crate is re-exported in Leon. However, the documentation for Leon does not show it. All right. Now we need some sort of object, path, option, path. This is a typing with gloves day. It's 51 degrees in here. Like a meat locker. So meat lockers are colder than that. Oh, there it goes. Now it's checking all that stuff. All right, so we're going to start to fill this in. I guess we could just create a path. Does path have default? Default it does. Or maybe we just never collect the mesh. We can do that at the very end. Okay, so we're gonna have to map these instructions. Ah, my mistake. We needed a path builder. Does this not have default? Why doesn't it have default if it has new with an empty constructor? Alright, so we cannot derive default now. But we can have a path builder in there. Rename this. See, this is one of those things that I would like to have in our other project. I know that this being so small, TS server could figure it out in JavaScript. Oh. That's unexpected. Leon. Path. Path. And path builder. Is that hidden? What's a trait? Path builder is a trait. Okay, I conflated the two. So if the type, what is the type here? The type is builder. Documentation. Builder, no. Path, no. Leon. All right. For convenience, I have not found this convenient at all. Let's just import Leon math, or path, excuse me, for now. All right. Come back here, go back to the text, Leon path. You know what? I'll bet I could figure it out now. All right, it's indexing. Give it a minute. How's everyone's weekend? So new on that. Native class, fine. Builder. Look at that. It can figure it out. That is so much more convenient. All right, so we have a new builder. Yeah, so I've got a ceiling to fix, a different ceiling. When it rains, it pours, right? The dishwasher had a leak, and so now I get to fix another ceiling. So exciting. So very exciting. I've actually put it off. I've now got a hole in the ceiling that I am just dreading fixing. All right, and what does Path Builder have in it? So Path Builder has begin, end, line 2. Ah, so we could do a begin at point, end, line 2. Close. Add circle, add rectangle. Wow, okay. A lot of stuff in here that we don't need. Yeah, I'm guessing it's going to be begin. Point 2D, F32. Do I have to do that? Or can I just give it a tuple and say into? Because I think it's using, was it, it's using, okay, this point is re-exported from Euclid. And I think Euclid can convert to and from tuples. All right, now let's go back to our line 2. We'll copy. There must be no subpaths in progress. I wonder what that would do. Might need to keep track of that. We'll see. All right, line 2. Self.path builder. Now it wants a new point. I wonder what the difference is between line path geometry point and math point. I guess we don't see geometry point. Line path. I might have chosen the wrong one. Oh, it likely re-exports the geometry class, which then uses the same point. All right. Let's use math point. Quad 2, self.path builder. Quadratic Bezier 2. So we have x1, y1, x, and y. But which is the control and which is the destination? Let's look. That's going to be in the TTF crate. Oh, stop it. Got docked. TTF parser. Outline builder. Depends a quad 2 segment. Oh, Thank you. Thank you for that. Well, let's try it in the order that they arrive. Well, let's see. Hold on. Quad 2. Let's look at the source. Let's not guess. Okay. We might be able to look at the SVG piece here. I don't know if they're trying to do SVG-like syntax. It might be. All right. Just go forward and see if this is correct. So we have x1, y1. Is it x and y? Curve 2. It's going to be the same thing. Yeah, here we have 2 control points. Oh, interesting. Maybe we can figure it out. Because here we have x1 and x2 and then x. So maybe the control points are the numbered ones. Did we get that in the same order? Yeah, the control point came first here. It's control 1, control 2. X2, Y2. And then X and Y. I think it's called N for what we want. Isn't it builder? Path builder? Oh, this is line geometry. Path. There we go. That should be that. Begin and line 2 quadratic. Okay. Ooh, interesting. Flows. After this method is called, there is no subpath in progress until begin is called again. Interesting about close. Why wouldn't we want to close it? Let's say it is closed. All right, so there's that. That should give us a path builder with filled in bits. Yep. What does it mean? Yes. Oh, shorthand for builder and true. Okay. It's not helpful. So then we have that. We have an impl, and we want to get the mesh out. Build, take ownership of self, and we will provide. Oh, what shall we provide here? Something that could then be used inside of the glyph. Something simple. Let's figure out what that is. Self-path builder dot. Oh, wait. I'm gonna go back to Lyon. So we do all of those pieces, which I think we have wired up now. Oh, we have to call build on the builder itself in order to get the path. Okay, let's do that real quick. Okay. Then what do we do? Let's use our own custom vertex type instead of the default one. Say. I think we did something like that before because we had to use different types for Godot. Will contain the results of the tessellation. Okay, so we have a vertex buffer. More than sarcastic, Dante. How are you? How do you make an egg giggle? You tell it a yolk. Alright. Yeah. Recycled animations here. So, whoa, come back. We're gonna do a bit of geometry here. So we create a vertex buffer. My vertex buffer. We're just gonna use the default ones. Fill tesslator. Tessellate path. We give it the path with fill options. Interesting. That's the geometry. And then for each one of these, oh, this is how it converts from one type to the other using this callback function. Text rendering, yes. We're trying to get some 3D text rendered. And I don't have long short stream. Vertex buffers. My vertex, okay. Let's create a vertex buffer and a fill tessellator. Now, which crate do we think that's in? I'm guessing geometry. Oh, no. Okay. Is that in the tessellator? Ah. Vertex buffers. Alright, so it's in Lyon tessellation. Let's grab that. So there we have the path. Now, I don't think we have to do anything special to get this to work inside of Godot because Godot also uses Euclid for the points. So it might be okay there. Well, we might have to. Oh, they're just aliased, aren't they? With F32s. Try thinking ahead a little bit. All right, so where were we? Back over here. Let's create a vertex buffer, but I do not want to use our own type for that. Now it's going to want to know what those types are. Of course, we didn't tell it. Ah. Isn't that in... We looked at that. We saw it. It was down here. Vertex buffers in Leon Tessellation. Unresolved import. Something's wrong. Cargo check. Okay, so it's really just Rust Analyzer that's not doing so well. Let's restart that. GOC restart. There we go. So I was right. It wants the other types here. Now, hey, good morning. Growl. We are using this Challenger Deep. We also have these other commands. Thank you, Xenocron. So very useful. I mean, really, the commands command should say, commands brought to you by Xenocron. Okay. Now for this. Let's go to that type. Output vertex, output index. Let's see what their vertexes are. Now they don't have vertex there. Do they have a vertex defined here? Or oh, we should probably use the Godot one at this point, so we don't have to translate them later. We have vertex IDs. All right, let's look and see what the other side of this. Remember, we're over in this area, and we're going to start to get over to the Godot side of things. So we need to know some of the Godot types. GD native. We're going to be filling this into, let's see, a mesh instance. No, mesh. Not a mesh instance. Multi-mesh. A multi-mesh has a mesh on it. Okay. So we're going to be building this so we can create a multi-mesh. Ah, yes, array mesh. Thank you. Thank you, gentlemen. So if we were to create a new one, surface light map, add. Where's our from? Ah, add surface from arrays. There we go. Now it's a variant array of what? So this variant arrays is a variant arrays of other things. I think we figured this out once before. To a grep. I don't want to spend too much time rediscovering this. Not there. Not here. We did create an array mesh. Triangles mesh arrays into shared. And what is this mesh arrays? The variant array. Here's our vertices. All right, so we have a vector 3 array for x, y, and z points. Oh, that's right. We're gonna have to give these depth. And this vector 3 comes from GD native core geometry. All right, back to terminal 2. Vector 3 with, the second parameter. Oh, the index type. Yeah, use 16, probably just fine. Okay. And they did this extra block here for some of the scoping? What are they scoping? I'm going to create a new fill tessellator. Let's just copy this and then we will adjust it. Now we didn't have our geometry set up. Oh, that's our... So we have the point. We need to convert that to a vector 3. Miracle of sound. I noticed that when I enabled the YouTube safe music, that I ended up with a lot more Miracle of Sound. And this just has XYZ on it. It does have a new. Okay. X. Pause dot Y. And 0 out of 0. So we have the fill options, buffer builder, vector 3. That looks okay. Gonna let it finish doing its check. Alright, so after that, we will have our tessellator. We'll have our geometry. So that's what our end goal is, to have this, and then we will create that array buffer. Excuse me. Not an array buffer. We were just there. Array mesh. All right. What is the first value? What is a primitive? Is this a const? I think this is like a triangle mesh, things like that. We need to define that. There's our vertices, indices. Now we should already be in the right type, so we just need to get that out of there. Now in this case we wanted to swap X and Y, or was it Y and Z? I don't know that we're going to need to do that. Morning, Krasink. How have you been? And thank you for that. Gonna try to get some fonts built up here. We'll see how it goes. Now in this case we wanted an int32 array. Yeah, everything's doing all right. At work, man, the long project had a Git branch that has lived for 15 months. That finally got released this weekend. So now I'm at that point, right? It's like, well, now what? A buddy at work said it's like running a marathon, and then you get to the end. I'm not a marathon runner, but he is. It's like you get to the end, and then you just wander around not knowing where to go. It kind of feels the same way. And we only had one minor release issue, which was great. It was really minor. Alright, so now we're going to have to build these pieces up. Let's just grab this. Alright, now it doesn't know what this fill tessellator is. I think it's telling the truth. It doesn't know what. Oh, okay. That's right. Doesn't know what that is. Is it open source? I open source portions of my projects, not all of them. But this might end up being one of those pieces that I do end up open sourcing. And one of the other reasons why I wanted to do the tessellation, the font tessellation, was to be able to have shaders work on not just the fragment, but also the vertex shaders. So being able to do cool sort of effects with the font shapes themselves. Ah, sarcastic Dante, right on cue. Feels good to get it out. Yeah. It's been a journey. Let's import the rest of these. Let's give that a save. It doesn't know what fill attributes are. Do I have to give it that type here? Oh. Expected to take one argument. That's interesting. Required for the cast. Yeah, that should be a 0.2D. Oh, does it not know the end type? Expected signature of for lifetime fill vertex. Lifetime R. What's a fill vertex? What? Found signature function 0.2D. Here it's taking a fill vertex. Fill options. Something a little off here. Don't want to spend too much time trying to read through that. Let's see. We did that here. Yeah, this had fill attributes on it, and it just returned the point. Because later we end up converting the points. I do not think I have to do now. I would rather just do it once. I don't want the overhead of converting these later. Maybe it has to be the same type. Oops. Yeah, let's put that back. Now the fill attributes looks like it needs to be there, as seen in one of my other projects. But where does the fill attributes come from? Line tessellation.
The setting could hardly be
Hmm.
more perfect. New eyes, new vision for the world. An unparalleled blending of science and art.
Often it is difficult for a person to control a complicated
Unresolved import.
synthesizer quickly enough. A computer can take over much of this control work and do it more quickly
Did that
and
change?
accurately than a human being.
And all this has been just the beginning.
Cosmos. Cosmos cargo. Leon. Okay, this is 016. So something may have changed. Say dependencies, tessellation on 3, updated 9 days ago. Alright, where's your changelog documentation? No, go back. Maybe. Go to the repo. Changelog. That's not up to date. Releases. This is not up to date either. How about in tessellation? History. Removed unused imports. Fix incorrect tessellation when opposite side of monotone. Tessellator in the monotone tessellator because the reference X core navigation. It's nice to see it still being worked on. Updated to a new version of Euclid, but nothing else. Remove a clone. All right. So we have different versions of Leon. Fill attributes does not appear where I expect it to be. Is fill attributes just gone? Guess we could, do I still have the code for this? Let's open a new terminal. Hit status. Hit. With a dash L. Want to list them all. Show. I don't think it's set up. Git remote add. Great. Now we were looking for, was it fill tesslator? No, fill attributes. Let's search that now. Okay, all right. Well, documentation's out of date, or at least the example is. Hopefully the example should be better, right? WGPO. All right, here's our vertex buffers. Path builder with SVG. Oh, that's not what I want. Where's geometry is? Down here. So here they have tessellate path, given the path, fill options with fill rule. And they have a buffers builder. This is different. All right. How far off are we from this? Get rid of fill attributes. Come back to that stuff down there in a little bit. Fill options. We're using the default fill options. Yeah, this doesn't show off the function that I want to use. Okay, let's go ahead and delete that and figure it out. Let's go look at buffers builder. Buffers builder. Let's see. There we go. And what function we're trying to call new second argument. We're expecting to be able to give it a function. constructor. All right. Want a little bit more for this type. GTOR. I would rather this documentation be in the UI. I don't remember where it ended up. Let's see, this is, let's go back. It's not here. Buffers builder, okay, rendering the tessellated geometry. Example, okay. I want custom vertices. So here's my vertex, right? That's fine. Fill vertex constructor. Oh, interesting. That's different. Let's look a little bit more at this fill vertex constructor. Now we're gonna have two foreign types. Well, a foreign trait and a foreign type. We're not gonna be able to implement this for that, and we'll have to do the conversion ourselves anyways later. We're gonna have to use a new type on this, and then unwrap it later. Or we just don't. And do it once. Why do it twice? Okay. Now, what is this implemented for? Is this implemented on any type that they have? Or positions? Or F? Oh, hold on. Where F is a function that takes a fill vertex, returns an output vertex. So this is implemented for closures. Okay, let's put that back and try to map that. Oh, too far. Sorry. There, there. All right. Now this is supposed to return an output vertex, which I thought this was. So our geometry has a vertex builder here. We have a lifetime. Output vertex, which lives for that lifetime. Index, same thing in the constructor. I feel like we're missing something subtle then. This appears to just be some sort of conversion constructor.
No, there ain't no stopping us. Fly without boarding pass. Couldn't catch me, I be moving fast. Call me a
So it's expecting something of the type fill vertex. If we look here, this new takes where is fill vertex?
I said I'm moving too far. Getting fast. Looking at a shooting star. Got more than a couple of people.
Are they expecting this to be?
Said I might be big in a game like she went and got them breast implants. I said I'm moving too
My goodness, what are we listening to?
I'm ready to eat up track like
Because that's not what I read here. Signature function Euclid point 2D. Expect the signature of fill vertex. Okay, so let's just take a fill vertex instead. We'll get there. So if we take a fill vertex, now our code inside is going to be wrong. I'm sure import it, because fill vertex does not have an X and a Y like that. Oh yes. Fill vertex, where were we? Has a position, which then gives us a point, which is where we were before. Position. Then that'll return hopefully the right type, well, the new type. Interesting. Okay. And then on to the next bit, which I'm going to have to pick up tomorrow. Let's see, those vertices are going to be coming out of geometry there. I'll just deconstruct that. Expected semicolon. Why? Because I didn't give it a type. What is the geometry? There we go. Import that. Now let's give it a check. There we go. Ah, that one's off of mesh. Okay. Oops. There we go. Just clean it up a little bit. Okay, that seems to have done it. So now we should have an array mesh, which we can then toss into the UI. But I'm coming up on a meeting. Gotta get going. I love it when local Clippy is outdated and the one in CI reports an issue. Oh. Ah, yeah. Alright, we're gonna raid somebody that's running at way high quality there. I'm gonna have trouble watching his stream. Well, until next time, y'all, thanks for hanging out. Appreciate it. And hopefully we'll see some fancy font rendering. We'll have to work on word wrap, etc., etc. So, bye-bye.